Hi, today we'll be talking about the Dalton's laws of partial pressure. And this states that the sum of the individual pressures of all the gases that make up a mixture is equal to the total pressure, and that the partial pressure of each gas is equal to the mole fraction of each gas times total pressure. And now what does that mean? That means that the pressure of the whole mixture is equal to individual pressure plus the second part plus the third part, etc., depending on how much you have. And the second part of it says that most of our gas that we're looking for, let's call it gas X, divided by total moles times partial pressure is equal to, times total pressure is equal to the pressure of the gas that we're looking for, X. Now let's do an example here. We have a 54.0 ml sample of oxygen is collected over water at 23 degrees Celsius and 770.0 torr pressure. What is the volume of the dry gas at standard temperature and pressure? And they also told us that vapor pressure of water at 23 degrees Celsius is equal to 21.1 torr. Now we're looking for the gas at standard temperature, right? We're looking for the oxygen. So now first we need to find the partial pressure of oxygen. And we have total pressure of this much, 770, minus the water pressure, which is 21.3 torr, 21.2 torr. And now that should give us 748.9 torr. And now this is the partial pressure of oxygen. Now let's create a PVTN chart. Alright, number of moles, we're not worrying about number of moles. So pressure in the beginning, we have 770. No, in the beginning, we start off with oxygen only, 748. And then we're going to standard temperature and pressure, which is 760, right? We're only taking account of oxygen because we do not really care about water. We're talking about standard volume of dry gas of oxygen. Now this is the initial, final effect. Now volume, we're looking for the volume. We're looking for X, and they say we start off with 54 ml. Finally, temperature. We start off at 23 degrees Celsius and end off at standard temperature, which is 0 degrees Celsius, aka 273 degrees K. Now, what is 23 plus 273? That is 296. So we start with 296 degrees K. Now we're gonna have to use our other gas laws to find if P increased or decreased. Now, what happened to pressure? Pressure increased. Now, pressure and volume are indirectly related. So an increase in pressure means a decrease in volume. So first we're going to use volume, which is 54, times decreasing, which is 478 will go on top, 748 and 760 will go on bottom. And now we stop looking at P and we look at T. Temperature and volume are directly proportional. So as T decrease, V will also decrease. So we're also going to put a smaller number on top and the bigger number on bottom. And what does that give us? 54 times 748.9 times 273 divided by 760 divided by 296. And that gives us 49.1 milliliters. Now our second example, it says a mixture of 2.0 moles of H2, 3.00 moles of NH3, 4.00 moles of CO2, and 5.00 moles of N2 exerts a total pressure of 800 torr. What is the partial pressure of each gas? And now for this one, we're going to first add up all the moles. We have 2 plus 3 plus 4 plus 5. which should equal to 14. Now the total pressure is 800. So let's first write H2. All right, H2. Now H2 contains 2 moles out of the 14 moles, right? From here, partial pressure is equal to most of what we're looking for divided by total times total pressure. So we have most of H2, which is 2, over 14, which is total, times our total pressure, which is 800. And the same will be for NH3. It will be the number of moles of NH3 divided by the total number of moles of gas in this, which is 14, times 800. CO2 will be the same, except this time will be 4 moles over 14 times 800. And N2 will also be the same, except it will be 5 over 14 times 800. And that is how we find the partial pressure, really. So we have 2 divided by 14 times 800. So this one will be 114, let's round it, row 3, torrs. The next one will be 3 divided by 14 times 800, which will be 171 torr. Next one we'll have 4 divided by 14 times 800, which is 228 torr. 5 divided by 14 times 800, which is 286 torr. And now this one should be rounded to 229 torr. And if you add up all together, 114 plus 171 plus 229, it should be equal to somewhere near 800. So yes, that is 800. So our total answer is 800 torr. And these are the partial pressure for every single gas. We're going to be doing some more examples with partial pressure in the next video. Thank you for watching.